Alright, what's up guys? Welcome back to another video on AA learning. Just before I get into the video, sorry about the upload schedule and not being it being weird because I've been really busy for a couple months, but hopefully I'm gonna be back recording videos. I'm gonna try to do once a week, but yeah, this video is gonna be about exponential functions. So before we actually get into what are exponential functions and explaining exponential growth and decay, I actually have like a little warm up for you guys. So I'm gonna show two patterns here. So pattern A, and then I'm just gonna do a separate text box. Actually, we'll just write pattern A. So pattern A is going to be have these numbers 2, 5, 8, 11, and 14. And then we have another pattern, pattern B, and this is gonna have 3, 6, 12, 24, and 48. Alright, I want you guys to pause the video or just think your head really quickly. What do you guys see is the real difference between these two patterns? Okay, so hopefully you guys figured it out, but pattern A is basically adding plus 3 each time. We go 2 plus 3, that's 5. 5 plus 3, that's 8. 8 plus 3 is 11. 11 plus 3 is 14, and so on. So that pattern is just adding 3. And that's something that we call this a linear pattern because it's by a constant just adding by a constant number. That number that we're adding is not changing. Now pattern B is an exponential pattern. Exponential pattern. And that's what we're going to learn about today. This particular one is exponential growth, and it's being multiplied by 2 each time. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. 24 times 2 is 48. So the difference between really linear and exponential pattern is one's adding or subtracting. It could be subtracting as well. And then exponential is multiplying by that by that same constant factor. Okay, so now let's get into the really like what is exponential functions. So what is exponential functions? So I'm gonna give you guys both like the I would call this like the dictionary definition, but like it's more complicated to understand maybe, and I'll try to make it simpler to understand. So like the dictionary definition would be exponential functions are basically like functions where numbers are multiplied by same amount. I don't know why. Oh, I think that's yeah. The same amount every step instead of adding or subtracting. So of course there's going to be exponential decay and exponential growth. I'll get into those later, but a simpler way to interpret that definition there is basically it's where numbers grow or shrink by same factor each time. I feel like that's more simpler to understand. Like it's just grow, like I we saw in an example, it's just multiplied by 2 each time. 3 times 2 is 6. 6 times 2 is 12. It just kept going, like so on and so forth. Okay, now let's go into like the more math focus on this exponential functions, and that's how it's usually written. So when you see exponential functions, you'll probably see it in this notation. So f of x is equal to a times b to the power of x. Okay, so now when you understand these parts, each part of the function, right? So let's start with our a value here. So our a value is considered our initial value. This is like this usually when you see exponential problems, they'll be given to you in like word problems, or it's not going to be given to you like this is a, this is b, and just solve for x or something like that. It won't be like that. It's going to be like in word problem form. You guys are going to kind of have to like decipher it per se. But the a is like the initial value. So what this is, from the initial value, we can tell the y-intercept. And this can be helpful if we have to graph, for example, an exponential function. So an easy way to remember like the a value is like a starting seed. Like either I'm gonna draw. This will make more sense when I draw the graph. I'll show you guys when comparing exponential growth and decay. But think about it as a starting seed. That y-intercept is gonna be the x is gonna be 0 and the y is gonna be some value. So you're starting at a certain value always, and either shooting all the way up in growth or just shooting down in decay. So it's gonna be one or the other. Okay, and now let's talk about the b value. So the b value is basically this is the main portion, I would say, of exponential functions that can sometimes trip people up, is growth slash decay. Okay, so growth and decay, these two words are going to be important for exponential functions. So if something it wants to exponentially grow, it has to be in between, it has to be, if something exponentially grows, so I'm just going to write g for growth, it has to be greater than 1 on the inside. So in this a times b to the power of x, we have a, and this inside value has to be like, let's say it's 1.1 to the power of x. So no matter what this a value is, if it's like, let's say this a value is 1000, right? Let's say we're starting with 1000 of something. We don't know what that is. And the growth of the b value, or the growth factor in this case, is 1.1. We're growing by 1.1, and depending on the x is, it could be years, months, we don't know, the word problem would say. But depending on that, we're gonna grow. Our graph is eventually gonna go up like this. So again, that a value being the y-intercept, that's where, like, if you plug in 0 for x, because y-intercepts, remember, is 0 comma some number here, you plug in 0 for x, the value right here is just going to turn to 1, and this a value is really that y-intercept of yours. So in this case, it would just be 1000. So that's like your starting seed, like I said. And yeah, so now let's get into exponential decay. So exponential, let me clear this all out. Okay, so exponential decay, we'll just write d for decay here, is any numbers that are in between 0 and 1. So this is important for you guys to understand, because the b value has to be between these 0 and 1 values. It's never negative usually, and if it's negative, it's like you usually in, like, this is taught in algebra 2 course class, so you usually won't get a negative value. That's more for more advanced topics. But for these when it's decay, it's always gonna, the b value is always gonna be in between this 0 and 1 number. So again, I'll give that example where a is the initial value of 1000, let's say, and let's say our value is 0.99. Now, even though this number is close to 1, yeah, it's really close to 1, but it's still gonna eventually decay, and our graph is kind of gonna look like this. So we're gonna start up high somewhere, and then we're gonna go down, but it's never gonna touch 0. This graph is always gonna be like hovering a little bit above 0. So it's just never gonna reach 0. So let me guys, now I'm gonna go through some examples. Okay, just to like recap, I'm gonna do f of x is equal to 2 times 1.5 to the power of x. So this 2, as we said, because it's on the outside, that's our a value, and this 1.5 would be our b value. And because our b value is what's it called, growing, it's greater than 1, that's why it's growing. So yeah, now if we had something like f of x is equal to, say, 20 times 0.3 to the power of x. Now we know our a value again will be 20, our b value this time will be 0.3, and because it's in between 0 and 1, we know that it's exponential decay. Okay, now I'm going to give you guys 3 practice examples, and I'm going to go through these practice examples. They have exponential growth and decay explained, and if you guys need more practice or anything, I'll have linked a Google Docs for practice. There's 10 practice problems you guys can do there that I created. So let's go through the practice word problems. And yeah, these are going to be word problems, so yeah. It might be similar to what you guys might see in your classroom. So first one is, you have $1,000 in a bank account. Let me make this bigger. Yeah. Okay. it gains 5% every year. How much will there be by 10 years? Okay, this is a really standard type of question you guys will see for exponential problems. So let's show you guys the steps. So first, what I like to do for these problems is label like the parts we need to know. So we know there's an initial value of $1,000 in the bank account, and we know initial is the A value. So we'll just write A, and then I'm gonna write $1,000. And then we know that it gains 5% every year. It gives us that it's a growth function. So I'm just gonna write G is 5%. We don't even have to figure out if it's growth or decay. It straight up tells us, okay, gains 5%. And then we have to find out how much it'll be after 10 years, by 10 years. So we figure that out after putting it into the equation. So in this part, I'm gonna write out the equation. So f of x is equal to a times b to the power of x. Okay, so this is our exponential growth, just exponential function equation. So let's just fill in what we have. So f of x is equal to 1,000. So this is the part that people kind of get confused in. They just plug in the 5%, but that's actually not what you have to do. So this is 5%. The exponential formula, the b, we don't put percent in there. So 5%, you guys have to remember, is the same as 5 over 100. And we gotta remember, if it's growth, it's 1 plus something. Remember, it's greater than 1, so it's 1 plus something. And in this case, that's 5%. So what we have to do is 1 plus 5 over 100, and that will equal 1.05. That is what actually goes inside this parenthesis right here. So we put 1.05 right here to the power of x. So that's our exponential function written down. Now we actually just need to solve the problem. So we know it says we need to find how much money will there be in the bank account by 10 years. So all we gotta do is do f of 10 is equal to 1,000 times 1.05 to the power of 10. And I already put these calculations in beforehand, and this usually approximates to 1,628, and let me add the dollar sign, 0.895. I rounded the 3 decimal places. I recommend you guys also start doing that, because if you guys take AP classes or something like that, my teachers at least wanted me to round to 3 decimal places, and it's good practice for like AP exams. So yeah, so that's the first problem. Let's move on to the next one. Okay, all right, so the next problem is going to be a bacteria population starts at 80. Okay, sorry if the wording is not the best here, but starts at 80. The bacteria population triples every hour. How much bacteria are there by 5 hours? Okay, this is a more trickier question, I would say, compared to the one we had previously, but let's just start off with what we know. Okay, so bacteria population starts at 80. So that means our initial value, A, is going to be 80. And then we know that the population triples every hour. So that actually makes it really straightforward for us to triple. When you think about that, bacteria population triples. When something triples, it increases. So that means that B value is just simply going to be 3. And then we need to find how much the bacteria there will be at 5 hours. So we know X is equal to 5. I'm just going to label hours. So now let's write our function. We know f of x is equal to a times b to the power of x. So in this case, let's write down an exponential function. F of x is equal to a, we know is 80, times b, which is 3 to the power of x. That's our exponential function. Now let's plug in what we need to find, 5 hours. So that's f of 5 is equal to 80 times 3 to the power of 5. And that answer is 19,440 bacteria. I'm just gonna write B for short. But yeah, that was actually simpler for us because it simply just gave us triple and we just knew 3 there. So yeah, that's our answer for that question. Again, if you guys need practice with this, I'll have a practice Google Doc that you guys could use that has 10 practice problems. So yeah, let's go to our last example for today. Okay, so a car is valued at $100,000. But it loses 18% of its value every year. I'm gonna try to shortcut the writing, but mine is 18% every year. How much value after 4 years? Okay, so this problem we need to identify. Remember, first thing, A is equal to 100,000. So our initial value is $100,000. Let's write that there. A is 100,000. I'm just gonna write the dollar sign. Okay, but we lose 18% every year. So that's also important information. So what do we have to do in decay? We know what we do in growth. It was 1 plus. Now in decay, remember, it has to be between 0 and 1. So how do we do that? We have to do 1 minus, and remember, we have to turn this percent into basically decimal. So 1 minus 18 over 100. So that's basically equal to 1 minus 0.18. And that's equal to 0.82. Okay, so that's our B value. Okay, and we need to find how much that's valued after 4 years. So let's write our function, f of x is equal to a times b to the power of x. And then let's just plug in what we have now. So f of x is equal to our a, which is 100,000, and then times the b, which is 0.82 to the power of x. And now we know that x is 4 years, so let's just plug in 4 for x right here. Basically just rewrite the equation, but replace the x with 4. That. And then we should get an answer around 45,000. I'm gonna do dollars. 45,212.176. Okay, so that was exponential functions, exponential growth and decay. Again, if you guys need practice, there'll be a Google Doc in the comments. But yeah, thank you so much for watching, and yeah.